Why does one dead Christmas light kill the entire strand? But when your kitchen light burns out, nothing else happens. You think it's random, but it's not. It's a secret that's in your phone, your house, literally everything. And today, I'm going to expose it. We're going from this super annoying Christmas light to the insane physics that powers the world. I promise, by the end of this video, you will never look at electricity the same way again. Okay, this is the worst feeling in the world. You spend an hour untangling lights, you plug them in, and half of them are dead. You have to go bulb by bulb, finding the one that's holding the others hostage. It's a nightmare, but your kitchen light dies, and who cares? You'll fix it later. The other lights are perfectly fine out why. What is going on? The answer is so simple. There are two ways to wire electronics, and one is so bad it should be illegal. It's a one-lane road where a single crash shuts everything down. The other is a massive highway where traffic just finds a new route. Understanding this is the key to everything. The tale of two circuits, series versus parallel A circuit, is just a racetrack for electricity. That's IT. But how you build that racetrack changes everything. Those awful Christmas lights. They use something called a series circuit. Imagine a one-lane road. The electricity must go through the first bulb to get to the second, and so on. So if one bulb dies, the road is destroyed. Everything stops. The entire circuit is dead because there's only one path. Some bulbs have a tiny shunt that's supposed to fix this. But let's be real, they never worked that. But your house is wired by a genius using parallel circuits. This isn't a one-lane road. This is a massive 10-lane highway. The electricity flows down the main highway, and every single light has its own off-ramp and its own private loop. Every bulb gets the exact same amount of power. So if one bulb dies, who cares? The electricity just ignores that broken exit and the other lights stay on. That's why your entire house doesn't go dark when one bulb burns out. It's also why those giant old C7 and C9 Christmas bulbs were so much better. We solved the Christmas light mystery. But what are current and voltage? For that, you need to meet the three main characters of electricity. The building blocks, voltage, current, and resistance. To understand any of this, you only need to know three things. We're going to use a water pipe analogy because it makes it so easy. First up is voltage. This is the pressure, the push. A giant water tower has way more push than a small one. And a wall outlet has insane voltage compared to a tiny battery. Next is current. This is the actual flow. How much electricity is moving. When you flip a switch, you're letting the pressure, voltage, create a flow, current. And last, resistance. This is anything that slows the flow down. We use copper for wires because it has basically zero resistance. But listen, resistance isn't the enemy. We use resistance to do awesome stuff. The little wire in a light bulb is just a resistor that fights the current until it glows. The coils in your toaster are just giant resistors designed to get insanely hot. We measure this in ohms, omega, that these three things, the push, the flow, and the opposition, are all connected by one perfect rule that is the secret to all electronics. The golden rule. Ohm's law, a guy named George Ohm, gave us the ultimate cheat code for all of electricity. It's called Ohm's law, and it's the only formula you need to know. Are you ready? It's this simple. Voltage equals current times resistance. That's IT. The secret to everything is V equals I times R. It just makes sense. More push, voltage, means more flow, current. More resistance means less flow. Engineers use this every single day. If you connect an LED to a 9-volt battery, it gets way too much power and instantly explodes. Pop. So to stop that, we use Ohm's law to find the perfect resistor to protect it, and boom, The LED lights up perfectly. Here's a quick example. A 120-volt outlet and a normal 60-watt light bulb have 240 ohms of resistance. Using Ohm's law, I equals V slash R, you get 120 volts divided by 240 ohms, which is 0.5 amps of current. You want a brighter bulb? You need less resistance to get more current. It's that simple. This one rule unlocks everything. Application and reinforcement. The math behind the light's okay. Let's go back to the Christmas lights, but now we have a superpower. Ohm's law. First, the awful series lights. Say you have 50 bulbs, and each bulb is 10 ohms. In series, you add it all up for a total of 500 ohms. Now, for the current. That's 120 volts divided by 500 ohms, giving you 0.24 amps. But here's why they suck. The voltage gets divided between all the bulbs. Each bulb only gets a tiny 2.4 volts. And the craziest part? If you add more bulbs, say 100 of them, the resistance doubles to 1,000 ohms. The new current is only 0.12 amps. It gets cut in half, and every bulb gets super dim. It's terrible. Now for the parallel kitchen lights. This is where your brain is going to explode. Every single light bulb gets the full 120 volts. Every single one. Let's look at the current for one bulb. I equals 120 volts slash 240 ohms equals 0.5 amps. But if you turn on a second light, the total current is now 1 amp. For lights, 2 amps. In a parallel circuit, the more things you add, the more power you pull. And this is why your house has circuit breakers, to stop you from plugging in a heater, a microwave, and a hairdryer, and pulling so much power that you literally burn your house to the ground. Expanding the world. Circuits are everywhere once you understand this. You will see it everywhere. You know what a power strip is? It's a portable parallel circuit. Each outlet is a new branch getting the full 120 volts. But series circuits are used for genius things, too. Inside your phone, they use them to divide voltage so a 5-volt battery doesn't destroy a 3-volt chip. It's an insane life hack, but everything we've talked about leads to the biggest secret in this entire video. That water pipe analogy we used, the idea of electricity flowing through a wire, it's a lie. The deepest secret, how energy really flows, this is going to break your brain. The idea of electrons flowing like water is completely wrong. The electrons in the wire move slower than a snail. So how does the light turn on instantly? Because the energy isn't in the wire. It's in the invisible field around the wire. A guy named Poynting figured this out. You have an electric field from the voltage and a magnetic field from the current. When they meet, they create a flow of energy called the Poynting vector. When you flip a switch, the energy leaves the battery, travels through the air around the wires, and dives into the bulb from the sides to light it up. This is crazy. The wires are not pipes. They're just guide rails for the energy field, which moves at nearly the speed of light. This is the deepest secret of electricity, and almost no one knows it. So we went from a stupid Christmas light all the way to the biggest secret in physics. You learned about series and parallel circuits. You mastered the 3 parts of electricity and the one rule that controls them all. V equals I times R. We saw why series lights are dim and why parallel circuits need breakers. And you learned the ultimate secret. That energy doesn't even flow in the wires. It flows around them. The entire world is built on these secrets. So the next time you flip a switch, you know you're guiding invisible energy at the speed of light. If you want your mind blown with more science like this, subscribe right now. Don't miss the next video. Thanks for watching.